My name is Sebastian Klenk. I'm the founder of 5Analytics. We've been doing AI for the last 3 to 4 years as a startup. Before that, I was doing my PhD in that area. And what our goal is to actually bring AI into the enterprise. So we don't consider ourselves, let's say, data scientists or experts in the field of developing algorithms, but we want to cover the whole area from the initial idea to actually go live and have a running system that actually makes decisions automatically. And the previous talk was, or the previous presentation was actually a perfect introduction. Because if we talk about AI, what we usually see are some of those typical use cases, predictive maintenance. Whenever AI is covered, somebody's talking about predictive maintenance. But a lot of companies we were talking to, they said they don't even know what a failure or a downtime costs them. They know that downtime is bad, okay, so we should reduce downtime. But if we can say, okay, we can reduce your downtime by, let's say, 10%, how much would you be willing to pay? And they don't know. And if they don't know, then it doesn't make sense to actually reduce downtime, because every piece of downtime you do, or you reduce, might be good or might just not be good enough. So if we look at AI, there are like 3 challenges. And the first one is not every AI case is actually a good business case. And usually what we see in the media is not the best use case to start with. Those use cases you read in Handelsblatt or so, they're usually very, very interesting, very challenging, and they do make sense in a way. But are they really the best ones to start with? And I really love the click example, because it's exactly what the first use case should be about. It's a rather simple one. It's from a AI perspective, something that's probably good solvable. It has a benefit, because if you don't have those clicks perfectly together, your customers will complain. And it's something you can probably, it's very, very narrow. You don't have to interact with a lot of IT systems. So finding a good use case is actually a challenge. The second one is, data scientists are excellent and awesome in developing AI code, but they might not be the right people to actually develop the code for your 24/7 systems. And they might not be the ones who truly understand your business. But that's okay. So what you need is someone to mediate, to talk, and to cover the bridge or the gap between business and machine learning. And the third one is actually a problem that's coming pretty far in the project, but it's a truly challenging one. The integration of AI code with your enterprise systems. Once you've reached a point where a prototype or a proof of concept doesn't do it, you want to integrate it. And then you have like challenges that your code needs to be running 24/7. If you're working in a production environment, usually production runs 24/7, and your code should be running 24/7 as well. If there is a downtime, there should be someone capable of maintaining your code. And it shouldn't be the PhD who developed the code, because you don't want to have PhDs 24/7 in 3 Schichten. So you need actually a system that is monitored by the IT, that is run by the IT, and that is integrated with your IT environment. And that is actually a challenge, because the tools data scientists use are not capable of doing that, at least not with a lot of effort. So those are basically the 3 main challenges. Okay. I go a step back. Why is AI important? I think most of us really know AI is important, and digitalization is important. But I'd like to highlight that with one example. And that's actually Amazon. Amazon has filed a patent to deliver packages before they are ordered. Okay, we have to let that sink for a second. Amazon is going to deliver a package before they are actually ordered. And the idea is pretty simple. What Amazon does is it says we can predict what packages are going to be ordered by what customers. If we look at, for example, let's say Christmas time, then even I can predict what's going to be ordered in Germany. Let's say socks, ties, and maybe some books or something like that. But Amazon has so much data that they can narrow that down to an individual, let's say a very small area. A couple of houses in Stuttgart, skyscraper in Frankfurt, or something like that. And they can narrow it down to any point in time. So they can say, okay, this book is most likely going to be bought in that area in Frankfurt tomorrow. And if they know that, they can ship it, even before someone actually orders it. And the benefit is that when someone is actually ordering it, the mailman just has to write the address on it and deliver it. And that has a couple of very, in my opinion, interesting implications. The first one is, for the customer, the delivery time has reduced from, let's say, 2 days to actually a couple of hours. And that's pretty impressive. But on the other hand, for Amazon, the delivery time hasn't changed a single bit. The package is still, let's say, 2 days on the road. The only difference is that once an order is placed, the package is much closer to the actual customer. So Amazon doesn't change anything in the actual delivery time. It just changes the experience the user has. And how does it do that? There are a couple of resources. I mean, these resources are the delivery centers. And Amazon is now assigning the products to those resources in the most efficient way to guarantee the shortest delivery time. And that guarantees that your customer, your experience, is as good as possible. And this idea of assigning resources basically matches all AI projects. If we look at predictive maintenance, we also have a resource, a machine. And that machine can produce products. And that machine has downtime. And what we want to do is we want to schedule the maintenance in such a way that downtime is minimized. And the algorithms used here are actually the same. There's no difference. And the algorithms all follow a very simple pattern. And that is, in my opinion, the second really interesting thing about AI. AI has like 3 steps. You have a sense step, where you take in sensory input. You have a learn step, where you combine that input with the experience you've made. And the third one is you act on new sensory input. And I want to show that with an example, but first I want to highlight what that actually means. We all as humans do those 3 steps. So, for example, if we meet someone for the first time, we look at that person and we judge that person. If we like it or not, we do that. And we judge that person not by, let's say, an in-depth analysis of what that person looks like. So we don't look at that person and say, oh, okay, there's jeans and a jacket and pullover. And then we start to analyze, okay, what does that mean? Does the jeans mean, okay, he probably doesn't work in an office and this and that? No, what we do is we compare the look, the visual input we have to previous experiences we've made. So we look for people we've seen before that look similar. And then we think, okay, did we like those people or didn't we like them? And then we assign that experience to the person we just met. And that's really important for AI, because AI works exactly the same. An AI algorithm doesn't analyze the situation in depth. For example, predictive maintenance. The AI algorithm doesn't think, okay, if that sensor has a high value, which basically means the screw is loose, and that means that this part is broken, and that leads to this and that. No, the AI algorithm basically looks at the sensory input and compares it to previous input which they had. And then the algorithm decides if that is a good or a bad example. There is one, in my opinion, example to highlight that. If we go to a doctor, we don't feel well, and the doctor assigns us let's say, a magic fountain. There is a magic water, and if we drink that, we feel well. That fountain is on top of a hill, and we have to go there every morning. So for 2 weeks, for 4 weeks, every morning we go on top of that hill, drink from that magic fountain, and then we feel better. And yeah, the part is for us, okay, it's obvious, it was not the magic fountain that helped us, but it was the hike. But judging from an AI algorithm, the AI algorithm would say, okay, he was walking up the hill, he was drinking from that magic fountain, and he was feeling better. So, magic fountain works. And the next person that's coming, the doctor or the AI algorithm, will again assign the same treatment. So there was not an in-depth analysis of what was happening, but the algorithm was seeing, okay, magic fountain sickness must be working. The point is, and that's the crucial part here, as long as we have the same environment, that recommendation actually does work. Because if I get that treatment, okay, drink from the magic fountain, I still have to go up, I will be feeling better. But if I live close to that fountain on the hill, it won't help me. And the same is true for AI. As long as the algorithm gets the same input from the same environment, it will be able to predict stuff that is in line with what we have. If we change something, we can't do the in-depth analysis. We can only predict what is going to happen in the other case. What we've done here is a project we had with another company. The idea was to classify customers. So imagine you're going onto a website and you get like personalized information. And that's what we did here. We looked at website content. We extracted from those websites, let's say, keywords. We call it a fingerprint. Then we combined that fingerprint to data we had in systems, let's say CRM systems, social media, and all the information we collected in relationship to those companies who visited the website. And now the thing is, if a new company visits our website, it's in B2B, we visit the website of that new company as well. We get, let's say, sensory input, which is the input we get from the website. We compare it to the sensory input we already collected. And then we take the profiles we generated for those websites we already visited. And we can assign the information to that new company. And suddenly, we know a lot about that company, even though we don't have anything about that company besides their IP address. And that's actually the same way we would act. We have collected, let's say, information, we've made experience with people, we've looked at them, and we made experience they were nice or they weren't that nice. If someone new is coming, we see them for the first time, we take the experiences we've made, we put that in relationship to what they look like, and we choose the ones that look the most similar. And we assign the experiences we've made with the other ones that look the most similar to the one we have. And based on those experiences, we can now say, okay, that person is this and that, or here in our case, this company is that and that. And thereby we can, for example, classify customers. Okay, the last part is, how do we get that all into an IT environment? Therefore, we've developed a software that basically takes machine learning code and connects it to an enterprise environment. Connects it to your SAP system, your Salesforce, Oracle, whatever. Connect it to your authentication environment, to your backup system, to your monitoring environment, and connect it to existing databases, so that you don't have to worry about integrating your machine learning AI code into your enterprise environment. And basically that's what gives you the benefit of having like your machine learning code running in a highly secure environment, delivering AI information in real time. You can connect it to your legacy systems, and you can monitor your code. You can actually operate your code in an enterprise environment. Yeah, and that's it. I'm almost done.